Hello students, welcome to maths class. Today we will start one new topic, continuity, right? So from this topic you are going to get one 4 marks question. So actually if we are perfect with the limits, same limits formulas will be applied in this continuity. So what is meant by continuity means a function is said to be continuity at a point A, right? If it's that means if you see the graph of that function, right, at the point A, right, function is continuous. There is no breakage, right. It is continuous at that point. It is not breaking at that point. Then it is said to be the function is continuous at that point. Suppose this curve is breaking at this point, right, some point is there, then we can say that the function is not continuous at that point. Okay, so what is the meaning of function continuous at a point x is equal to a means graph is continuous at that point, that graph is continuous at that point. Okay, so here what are the conditions for any function to be continuous means first function should be defined at that point, right. Function should be defined at that point. That means we will say f of x is equal to x plus 1, f of x is equal to x square plus 2, or f of x value is 3, like that. That function must be defined at that point. And limit x tends to a, f of x must exist at that point. Limit must exist and that limit value must be equals to f of a, then we can say that that function is continuous at that point. Okay, so once again what is meant by continuous of a function is continuous at A means if we draw the graph of that function at that point, right, there will be continuous, no breakage will be there in the graph, then we can say that that function is continuous at that point. Now what are the conditions for any function to be continuous means that function must be defined at that point and limit x tends to a, f of x must be exist. Limit x tends to that point of that function must exist and limit x tends to a, f of x must be equals to f of a, then we can say that that function is continuous at that point. Okay, so mainly it should be defined at that point and the limit must exist. After that, if limit x tends to a, f of x is equal to f of a, then function is said to be continuous at that point. Then that function is said to be continuous at that point. Okay, so now come to the first question, right. Is the function f defined by f of x is equal to this is continuous or not? Is actually both we should, is continuous at 1, is continuous at 0 question, right. Is the function defined by this is continuous at 1, is the function defined by f of x is equal to is continuous at 0. So here function is defined by, it is given, and at x is equal to 1 also this is given that, so function is defined. Okay, so for any function to be a continuous, first it should be defined at that point and the limit of that function must exist and the limit of that function must be equals to f of a, that is the condition. So come on, first question, you take your first question, what is that? Function is given by, right, given that, right, what is the given information to you? F of x is equal to, right, set form, right, x square if x is less than or equal to 1, x if x is greater than 1, right. Given that f of x value is x square if x is less than or equal to 1 is equal to x if x is greater than 1, is continuous at 1 or not, we have to check. Okay, so function is defined, right. Now we will check whether the limit exists or not. So when we can say limit exists or not, we have to find whenever the function is given like this, x value less than 1, we can find a left hand limit, x value greater than 1, we can find right hand limit. So if left hand limit is equal to right hand limit, right, is equal to L, then we will write limit x tends to a f of x is equal to L, we will say it. Okay, so now try to find your left hand limit and right hand limit. Suppose your left hand limit not equal to right hand limit, that limit does not exist. Already we discussed these things in our limits chapter, right? If left hand limit is equal to right hand limit is equal to some value, then we will write limit x tends to a f of x is equal to L. Okay, so come on, now you take your left hand limit. Okay, so what is your left hand limit? Left hand limit is equal to limit x tends to, come on, 1 minus f of x. Always left hand limit means we will write 1 minus, right hand limit means we will write 1 plus, right? So is equal to limit x tends to 1 minus, if x value is less than 1, function is defined as x square. Now you substitute your x value. Already in limits, while finding the left hand limit, right hand limit, I said to you, 1 minus means 1 minus of very minute value which can be negligible. So its value is 1 only, right? While substituting the limit, we will take 1 only. 1 square is equal to 1. Next, you take right hand limit, right? So right hand limit is equal to limit x tends to 1 plus f of x. Okay, so if x value is greater than 1, function is defined as f of x is defined as x, right? So we will write limit x tends to 1 plus f of x value is x. So whenever it is x value is greater than 1, right, function is defined as x. And now you substitute your limit value. 1 plus means again same thing, 1 plus very minute value. So we can consider that as 1 only. So it is 1. Okay, so you got left hand limit is equal to right hand limit is equal to 1. Implies, what is that? Limit x tends to 1, f of x is equal to 1. You consider this as your first equation. So what is the condition? Limit x tends to a, f of x is equal to f of a. So x tends to a, in a place we are having 1. So f of x must be equals to f of a, that means f of 1 we have to find. So come on, now find f of 1. So f of 1 means nothing but f of x value. In x place we have taken 1. So it is x less than or equal to 1 is x square, right, is equal to 1 square is equal to 1. So you got f of 1 is equal to 1. This is your second equation. Okay, so from 1 and 2, what happens? From 1 and 2, limit x tends to 1, f of x is equal to f of 1. Okay, so implies, what is the condition? Limit x tends to a, f of x is equal to f of a. Okay, so that condition must be satisfied for the function to be continuous. So therefore f is continuous, right, continuous at x is equal to 1. Okay, so see the procedure. In the question, x less than 1 is given, x greater than 1 is given. So whenever in the question less than, greater than are given, we have to find left hand limit and right hand limit. If left hand limit is equals to right hand limit, that limit exists and we will get one value. right? So we will consider that as first equation. After that you find out f of that value. If limit x tends to a, f of x is equal to f of a form, then the function is continuous at x is equal to 1. Okay, so that is the procedure. Okay, so observe less than 1, so left hand limit we can find, greater than 1, right hand limit we can find. Okay, so if left hand limit is equal to right hand limit is equal to some value, right, then we can, that limit exists, right? It is a condition. If left hand limit is equal to right hand limit is equal to some L value, then limit extends to a, f of x is equal to that L value, right? So then we can write this as, we have to find f of a, and f of a and limit x tends to a, f of x both are equal, then f is continuous at x is equal to 1. Okay, so now come to the second question. What is your second question? So if f is defined by f of x is equal to sine 2x by x, if x not equal to 0 and 1 if x is equal to 0, is continuous at 0 or not. So function is defined like this. If x not equal to 0, this is the function. Function is defined like this, its value. And if x is equal to 0, function is defined with this value. Okay, so come on, given that, what is the given information to you? F of x is equal to, come on, it is sine 2x by x if x not equal to 0 and 1 if x is equal to 0. Okay, so in previous problem less than, greater than are given to you. So if less than, greater than are given to you, you go to left hand limit, right hand limit. If less than, greater than is not given to you, go to your third condition, try to get this condition, limit x tends to a, f of x is equal to f of a value. So come on, we have to find limit x tends to 0, right, f of x. X tends to 0, not x is equal to 0. So x is equal to 0, it is given like this. If x tends to 0, x not equal to 0, function is defined like this. We have taken x tends to 0, so not equal to 0. So we have to take this function, limit x tends to 0 sine 2x by x. Okay. So in limits, I said whenever sine is there, we will use one formula, limit theta tends to 0 sine theta by theta, that is equals to 1. So three values must be same, right? Theta tends to 0 sine theta by theta, these three values must be equal. So if you observe here 2x is there, so here we need 2, here we need 2. If x tends to 0 means x value almost equals to 0, 0 into something is 0 only. So we can write this as limit 2x tends to 0. Here we need 2, for that we will multiply and divide with 2. Okay, so and we don't want this 2, this 2 will come along with this x, you take that 2 outside, then limit, what happens, 2x tends to 0 sine 2x by 2x, right, it can be sine 2x by 2x. Okay, so what happens to this value? So it is nothing but 2 into, now only I said limit theta tends to 0 sine theta by theta form. It is formula previously. So theta means general form. Instead of theta, we can take any value. So here this value is equals to 1. So is equal to 2. Okay. So we got therefore limit x tends to 0, f of x is equal to 2. You consider that as equation number 1. Okay. Now you find out which value I said, limit x tends to a, f of x is equal to f of a. Try to prove this formula. If less than, greater than are not given to us. If less than x value, x is less than this much and x is greater than this much, we will go for left hand limit, right hand limit, then limit exists, then f of a. But if less than, greater than are not given to us, okay, then we have to go for limit x tends to a, f of x is equal to f of a form. So limit x tends to, in a form we are having 0, so we have to find f of 0 now, right? So come on, find f of 0. So f of 0, here f of x is equal to 1 if x is equal to 0 is equal to 1. Okay, how I got f of 0 is equal to 1? F of x value is 1 if x is equal to 0. That means in this function, in x place, if we take 0, then that function value is equals to 1. Okay, so that is your second one. Okay, that is your second equation. Okay, so from 1 and 2, what happens? From 1 and 2, limit x tends to a, f of x, right, not equal to, what is that? F of a. Why? Here from 1 and 2, your limit x tends to 0, f of x is not equal to f of 0. Isn't it? Observe, x tends, limit x tends to 0, f of x is 2, we got it, and f of 0 is equal to 1, we got it. So 2 is not equal to 1. So limit x tends to a, f of x not equal to f of a. Therefore f is not continuous, right? F is not continuous at x is equal to 0. Okay, so come on, what is this? Given that function is given as if x not equal to 0 and x is equal to 0. It is, function is defined in two ways. When x not equal to 0, x is equal to 0. So x not equal to 0 function we have taken at x tends to 0, right? Limit x tends to 0, f of x. That function value we have taken sin 2x by x. So it should be limit theta tends to 0 sin theta by theta form, isn't it? So we need 2, that's why multiplying and dividing with 2. So you take this 2 outside and that will be 2x. Okay, so limit 2x tends to 0, sin 2x by 2x value is equals to 1. It is very repeated standard formula in our limits. So limit x tends to 0, f of x, we got it as 2, and f of 0 is equals to 1. So limit x tends to 0, f of x not equal to f of 0. So it is against the condition of continuity. Therefore f is not continuous at x is equal to 0. So two ways, actually whenever less than 1, greater than 1 are given to us, we have to find left hand limit, right hand limit. If both are equal, that limit exists, right? Next, f of that particular value we have to find, right? So with that we will know whether the function is continuous or not. If in the question less than, greater than is not given, directly we will go to this condition. Where x not equal to 0, there that function is taken as the function of x tends to 0. And when x is equal to 0, that is f of 0 is equal to 1. So both are not equal, so it is not continuous function. Okay, so in any problem less than, greater than, left hand limit must be equal to right hand limit, then that limit exists. Find that limit value must be equals to f of that given point. Okay, so if less than, greater than are not given to us, right, then we have to find the limit x tends to 0, f of x value. Okay, so this value and multiplying and dividing with 2. Okay, so you will get it as a 2 2 and f of 0 value is 1, both are not equal, so it is not continuous function. Okay, be clear with the concept. So continuous means if we draw a graph for that function at that point, the curve will be unbreakable, it will be continuous. That's why it is said to be continuous function. Okay, that's all for today. Have a nice day.